Example 4. The mean 1 and variance 20. This time n is unknown. We don't know what is n. Okay? N observations of x. Given that 1% of the sample means exceed 1.5. Let us worry about how to interpret this later, okay? But before that, let us write what is x bar. X bar is the sample mean of n observations. So it must be x1 plus x2 plus all the way to x. N, I don't know what is n, divide by n. So far so good. Then by the result that we learned on Tuesday, then x bar must follow a normal distribution with the same mean, 1. And variance cannot be the same. Variance must be 20 over n. Can? Okay, good. Now, what you are given? You are given that 1% at 1% of the sample mean exceed 1.5. Now, this kind of 1% thing always comes out. You should have the ability to convert it into a probability. That means what we are saying is this statement. That means probability that the sample mean exceed 1.5 is 0.01. In the long run, 1% of the mean will exceed 1.5. It has the same meaning. This has the same meaning. What I'm saying? Okay? You convert that to a probability. Because by writing this, cannot help us. If you write this, it helps us. The probability that the sample mean exceeds 1.5 equals to 0.01. Now, this poses a slight problem because in example 2, example 3, we all know the mean, we all know the variance. You are required to find probability. In this question, you are required to find n because actually the probability is given. Correct? You are required to find n. So what do we first do? You cannot use GC now. There's nothing to use because you cannot find probability. You cannot use normal CDF. Correct? First thing, we standardize. Correct? We standardize because we are not required to find probability. We don't know the variance. So we standardize. So probability. I am a bit long-winded, so bear with me for this step only. This step a bit long-winded. Minus mu divided by standard deviation greater than 1.5 minus 1 over square root 20 over n. I know some of us would prefer to write this immediately as z. Correct? I am fine, but I just want to, for some of us who are not so familiar or a bit worried, I'm just doing the same operation on the left and the right. This is effectively just the standard normal. Follow? Okay. So if you want to write z here, I'm fine. Okay? Then, okay, very good, very happy now because we got a standard normal. Inverse norm. Inverse norm 0.01. Can or cannot? Cannot. Why? Because of this greater than sign. Follow? So, before we, sorry, I better be a bit proper, even though it doesn't make a difference. First, what we do is overrule n, the root n bring on top. That's all. Can? I haven't changed the inequality sign. Off. So far so good. Can? Why? Wait. What's the commotion? All okay? Wait, one more time. This one is probability. This is z, right? What is 1.5 minus 1 is 0.5 lah. Okay, 0.5. Then you have your square root 20, you put square root 20. Divide by root n, bring up. The root n bring up. Can? Good? Yes. Oh, because I changed the. Oh no, sorry, no equal sign. Ayah, what am I doing? Sorry. Salah. No equal sign. I'm so sorry. Means no. Okay, sorry. Thanks. I blur already. It's so warm here. What's going on? When all things fail, blame the temperature. Create an excuse. Okay. Now, like I said, you cannot inverse norm now because it's upper bound. So you change it to lower bound. Then you get a 1 minus probability z smaller or equals to 0.5 n over root 20 equals to 0.01. A bit long-winded Actually, most of us can jump from here to here. Sorry. Most of us can jump from here to here. Then you say probability z smaller or equal to 0.5 n over root 20 is equals to 0.99. Then you inverse norm 0.99. What do you get? You will get this, right? You will get 2. If you inverse norm, you inverse norm 0.9901. You will get this value. Okay, you try, you will get this value. What does it tell us? It tells us that then probability z smaller than 2.3263 is equal to 0.99. So immediately, then we can equate our 0.5 root n over root 20 equals to 2.3263. Correct? Then just solve. One equation, one unknown. Done. N. Find n. Done. Sorry, one more line. Question? All okay? Part 2. Part 2 is just a slight difference. Let's read the question. Now, instead of saying 1% of the mean exceed 1.5, now at most 1% of the mean. At most 1% of the mean. So, this is what we're going to interpret. That means the probability that the mean is smaller than 1.5 is at most 0.01. This actually means at most. Correct? Smaller or equal to sign and at most mean the same thing. Correct? Yep. So you must have the ability to convert that. Change the word at most to smaller than or equal to. Then it's almost the same problem. So I'm going to skip a few steps because you look very carefully from part 1. I am going to skip from, because this expression, I'm going to use from here, I'm going to jump right to here. Because these two are the same thing from part 1. Okay, from part 1 here, what I'm going to do is I standardize and convert to lower bound at the same time. Because I've done it in part 1, I'm going to do the same thing in part 2. I'm just going to write the same thing from above. Oh, sorry, this sign is wrong. Wait. This is smaller. Can? Oh, this is from above. We have just copied the same thing from above. Now be very careful when we do inequality sign. So now you will say, oh, okay, now I'm very good already. I z smaller or equals to 0.5 root n over root 20. Then you say this one must be 0.99. But be very careful what is this inequality sign here. Alright, what is this inequality sign? Is it a greater than or equals to or a smaller than or equal to? It must be a greater than or equals to. Oh. Not smaller than. You know why, right? Need me to explain? No need, okay, good. Then what do? Then we say, okay, now greater than, I don't know what to do. But actually, what we can do is we inverse norm 0.99, we'll get 2.3263. Then actually, what happens is this. From the GC 2.3263, probability Z smaller than 2.3263 is Z. This area is 0.99. This is what you get from the GC. Follow what I'm saying? This is what the GC tells you. The GC tells you this thing. When you inverse norm 0.99, you get 2.3263. GC is telling you this. Yeah? GC is telling you that. But what do we want? We want probability Z smaller than particular value, whatever this is. I want the area, I want the lower bound area to be greater than 0.99. So I want the lower bound area to be greater than 0.99. My critical value here must lie here. Not here. It cannot be here. Because I want my lower bound area to be larger than 0. Follow. So quite obviously, now I say 0.5 root n over root 20. This inequality sign must get it right. Must be greater than or equals to 2.326. Which means n must be greater than 432.9. Then, since n is the number of observations, n must be integer. So set of values must be an integer, n greater than or equals to 400.